So here we go, continuing on in our trig series. Here is the sum to product and product to sum formulas. So the first one is the sum to product formulas. Here they are. Feel free to pause the video and write these down. These actually will be given to you, so you don't need to worry about any of that. These will be given. So yeah, basically they go from a product, right? You're doing sine of something times cosine of something, and these are what they end up turning into. However, if you notice what happens, right? This is going from a pretty simple equation to a way more complicated, difficult equation. So because of that, even though I am giving you, right, we're talking about the product to sum formulas, we aren't really going to be using these too often. Because remember, we want to simplify things down to get it where it's just a product or just a trig equation equaling a number, right? So because of that, the sum to product are actually going to be the way more helpful ones. And again, these will be given to you. But if you want to take a picture or pause the video and take a look at all this, that's totally okay too. But if we see, right, we're going from a sum to a product, and if you have all of this stuff equaling 0, right, the sum equaling 0 doesn't tell you anything, right? 1 plus -1 is 0, but 2 plus -2 is also 0, right? So that doesn't help you. You don't know anything about a sum equaling 0. However, you do know stuff about a product equaling 0, right? If you have x times y equals 0, one of these has to be 0. So that's why sum to product is actually going to be very helpful when it comes to these sections. All right, so we got 3 examples, and these are basically the exact same things we've been doing so far. We're going to be using our new equation. All right, so we got sine of 5x plus sine of x equals 0. Well, again, right, so we have an addition, a sum equaling 0. That doesn't help us at all. So let's try to see if we have a sum to product, and we actually do, right? Here is going to be our sum to product. So we can see that this is just going to be 2 times the sine of 5x plus x over 2. And I haven't memorized these either, so I don't expect you to memorize them, times the cosine of 5x minus x over 2 equals 0. So when we simplify that down, this is going to be 6x. 6x divided by 2 is 3x. If we do the cosine, right, cosine 5x minus x is 4x. 4x divided by 2 is 2x. And we can just divide off this 2 up the front, so we end up with sine of 3x cosine of 2x equals 0, which means, right, since we have two things being multiplied to equal 0, the first equation is that the sine of 3x equals 0, and our second equation is that the cosine of 2x equals 0. So one great thing about when it equals 0 is if you know what the graphs look like, these should be pretty easy equations to solve. So if it equals 0, right, we can just do our regular equation. Sine starts at 0, goes up, goes down, goes back up, right? This is a 2 pi. This is 0, so halfway is going to be pi. So how often is everything repeating itself? We see it's every pi, right? 0, pi, 2 pi, 3 pi would be next, right? 4 pi would be after that. So we know that the angle is going to equal pi n. So the question is, what is the angle? What equals pi n? It's the angle that we're looking at. What are we taking the sine of? It's 3x. So 3x equals pi n. To solve for x, x equals pi over 3n. So notice it says that our interval is between 0 and pi. So we can't just leave it like this. We actually have to figure out what are those numbers. And essentially, right, remember n just means any sort of integer, right? So 0, 1, 2, 3, -1, -2, -3, right? So we can see essentially what these answers are going to be. This can be pi over 3 times 1, which is pi over 3, 2 pi over 3, 3 pi over 3, which is just pi, right? That's 3 pi over 3, 4 pi over 3, 5 pi over 3, and you just keep going, right? It also is negatives, right? Negative, so I guess 0 would be the next one. So 0 pi over 3. You have negative 1 pi over 3, negative 2 pi over 3, and it just keeps on going in that direction, right? So this is us listing out every single, more or less, this is what the pattern is for every solution. But since we only want the ones between 0 and pi, right, then the only solutions that can happen are these three, right? The 0, the pi over 3, and the 2 pi over 3, because we're not including pi. All right. So next, let's look at the cosine of 2x equals 0. So remember, sine starts at 1, goes down, and goes back up. So if we establish this is between 0 and 2 pi, halfway is pi, so what's between 0 and 2 pi? This one right here is pi over 2. What's between pi and 2 pi? This is 3 pi over 2. So once again, it's pi over 2, 3 pi over 2. The next would be 5 pi over 2, 7 pi over 2, right? So on and so forth. So some of y'all might be tempted to say it's pi over 2n, but if you notice, right, pi over 2n, that'd be 1 pi over 2, 2 pi over 2, but 2 pi over 2 is pi. That's not an answer, right? So we're actually starting at pi over 2 and we're increasing by pi every single time, right? So it would be pi over 2 plus pi n. And what equals pi over 2 plus pi n? It's what we're taking the cosine of, that 2x. So then solving for x, we get x equals pi over 4 plus pi over 2n. And if you want to make it a little easier on you, right, get common denominator. So that's going to be over 4, so we multiplied by 2, which means we're going to multiply by 2 on the top. So if we list out all the different possibilities, right, we can start with 0 for that. So we got just pi over 4. We can add 2 pi over 4, which would be 3 pi over 4. Keep going, 5 pi over 4, 7 pi over 4, 9 pi over 4, right? It just keeps on going forever. We can go in the opposite direction, so negative. So we got negative pi over 4, negative 3 pi over 4, and that just keeps on going forever also. Again, we only want the ones between 0 and pi, so we can see that that would be pi over 4 and 3 pi over 4. Good, because remember pi is just 4 pi over 4. Cool. So we end up with 5 different solutions. Now here's the question, do we have to check ourselves? If you said no, you're absolutely correct, because we only have sine from the very beginning, right? So we don't have anything else. So we don't have to check ourselves, though it's always good to check, but we don't have to. That's not part of the equation, not part of the problem. Let's do some more. All right, so right now we got cosine of 3x equals negative cosine of 6x. Now, first thing, you cannot do. There's a couple things you can't do, and I know some of us are going to really want to do that, right? What's the first step? Some people are going to just want to say, oh, let's just divide by cosine, right? So then we get 3x equals negative 6x. That is not correct, right? Cosine is a function, just like the square root is a function. You wouldn't say square root of 2 equals square root of 7 divide by square root, right? No, we're actually doing something to get rid of that square root. We don't just divide by square root. So that doesn't make any sense. There we go. So we can't just divide by cosine. Another thing we can't divide by, you can't just divide by 3 in this case. To be cosine of x equals negative cosine of 2x. That's also not allowed. And again, it's kind of like if you have 2x squared, you can't divide by the 2 inside because those exponents, the actual function happens first, right? You have to do that first. So, because right, if you notice, it'd be 2x squared is 4x squared. So if you divide by 2 to the inside first, you end up with x squared. But if you divide by 2 here, you end up with 2x squared, right? These aren't the same, and that's because you can't divide first. Kind of the same thing with here, right? You can't divide, you have to take the cosine first. So none of that's going to work. So maybe we can get it to where we have Because remember, the whole point is we want a trig function equals a number. Trig function equals a number. And right now we have trig function equals trig function. So maybe we can get both trig functions on the same side. So we get cosine of 3x plus cosine of 6x equals 0. And again, adding two things equaling 0 doesn't really do anything. So what we can do instead is we can try to see if there is a formula for sum of the product. And there is, right? So using this formula, right, we see that we're going to have, that's the same as 2 times cosine of 3x plus 6x over 2 times cosine of 3x minus 6x over 2 equals 0. Good. So we see that 3x plus 6x is just 9x. 3x minus 6x is negative 3x. Good. And, right, we can just divide everything by 2 because this 2 is on the outside. So what we end up seeing is that we have two equations. One is the cosine of 9x over 2 equals 0. One is the cosine of negative 3x over 2 equals 0. Because we have two things being multiplied equaling 0. And if you kept the 2, that's totally okay too, right? You could say it's 2x cosine of x over 2 equals 0, and then you divide by 2 here. So then you end up with the same thing, right? Super doesn't matter. All right. So let's try with the first equation. So once again, we got things equaling 0, and if you remember, we actually already did this, right? So when cosine equals 0, it's at pi over 2, 3 pi over 2, 5 pi over 2. Remember, we had pi over 2 plus pi n. We already did that from the last one. And that's one great thing about these, right? You already figured out once. The only difference is going to be the angle that we have at the very beginning. And that angle, instead of just x, it's 9x over 2. All right. So we multiply everything by 2, right? We end up with 9x equals pi plus 2 pi n. Then we can divide everything by 9. So we get pi over 9 plus 2 pi n over 9. And was there a interval this time? No, there was not. So we are good. That's where we can stop. That is our answer, or an answer. Now let's look at the second one. So one thing we can do is the exact same thing we already just did, right? So we know that it equals, cosine at 0 is going to equal pi over 2 plus pi n. And we can just tack that on to have negative 3x squared. And you absolutely can do that. However, because the homework is multiple choice, right? What they probably are going to do is they're going to, negative angles are no fun, right? So how can we turn it into a regular angle? Some of y'all might be saying, well, we could add pi n to it, right? But that's going to make things a little too complicated. We can look at the nature of cosine, right? What happens when you have a negative inside of a cosine? Well, if you remember, cosine is even, right? It's an even function. So then what happens to the negative for even functions? For even functions, the cosine just gets rid of the negative, right? It's like it was never even there. Remember, like if you have negative x squared, what's that the same as? Just x squared, right? It gets rid of it. Cool. So we can also do 3x over 2 equals pi over 2 plus pi n. And remember, we already figured that out from the last problem and from just this problem earlier. So once again, we can multiply everything by 2, divide everything by 3, right? Well, we can do it one step at a time. So pi plus 2 pi n, and then divide everything by 3. So we get pi over 3 plus 2 pi over 3n. Good. And if these are your answers, then you are absolutely correct on the homework or on the test. Full credit. However, let's see. We may also notice that this equation actually perfectly encapsulates this equation. So this is actually a superfluous equation and we don't need it. Because if you notice, right, if we have pi over 9 plus 2 pi over 9, that'll get us 3 pi over 9, which is pi over 3, which is right there. So this equation actually has all of the solutions as this one. But if you don't see that, that's totally okay. If you just give me these two equations and you circle them both, you get full credit. Don't even worry about it. But there may be a little discrepancy when it comes to the homework because the homework may just be giving this equation and you might get a little confused as to why. So that's why. Good. Do we have to check ourselves? No, we do not, right? We got cosines, so we're fine. Good. All right. So last one. Hopefully these are all seeming very, similar. Stuff we've kind of already done. We're just using an equation now. All right, so now let's consider the graph of the equation. Y equals cosine of x minus 3, or cosine of 3x minus sine of 2x. Let's find the 13 x-intercepts between these two values. So you should know this is going to be a very long problem. There are 13 x-intercepts, 13 answers that we are supposed to find. So first things first, how do you find an x-intercept? You make y 0, right? So y is 0, so we're just solving 0 equals cosine of x minus cosine of 3x minus sine of 2x. So you got a bunch of things being added and subtracted together to equaling 0, which does not help us at all. So maybe we can turn some of this into a product. So if we look at this one, right, let's just look at the first one. We could probably look at any of them, but the first one's going to be the easiest. So do we have an equation when you have two cosines subtracted? And actually, we absolutely do. So we can see, hold on a second. There we go. We can see that we get negative 2 sine. Again, I haven't memorized these formulas, which is why I don't expect you to memorize them either. So we got addition and then subtraction. So sine of x plus 3x over 2 times sine of x minus 3x over 2 minus sine of 2x, right? Good. So we got negative 2. So x plus 3x, we see that's just going to be 4x. 4x divided by 2 is 2x. X minus 3x is going to be negative 2x. Negative 2x divided by 2 is going to be sine of negative x. All right. So now we have a product and we have a subtraction. So, is there going to be a sum to product with multiple things, right? Well, unfortunately, no, right? It's just sine, just sine, just cosine, right? There isn't a sine times sine scenario, so we can't do something like that. All right, so we can't use the sum to product rule anymore. We've already used that up. So, what could we use? Well, if you notice, right, in this term, we have a sine of 2x. In this term, we have a sine of 2x. What can we do with that? If you said factored out, or thought factored out, then you would be correct. So we can factor out a sine of 2x. And when we do that, we end up with negative 2 times sine of negative x minus 1. Don't forget that minus 1. That's super important. Good. Now we got two things being multiplied together, right, to get us 0, which means that the first one, sine of 2x equals 0, and negative 2 sine of negative x minus 1 equals 0. So let's deal with the first one. So we got sine equaling 0, and again, we've already done this, right? This was the first equation. So that's another reason why I kind of like trig, especially these sections. If you do them enough, you start to see they're all kind of the same problem. So we can see that we're going to end up with it being equaling to pi n. And what equals pi n? 2x. So then x is going to equal pi over 2n. However, we need to make sure that we have all of the ones that they're looking for, right? And all of these are going to be between negative 2 pi and 2 pi. So that's different than what we are typically used to, right? So if we plug in 0 for n, we end up with 0. If we plug in 1, we get pi over 2. 2 is going to be 2 pi over 2, which is pi. 3 pi over 2. 4 pi over 2, which is 2 pi. 5 pi over 2, so on and so forth, right? We can go to the negatives. Negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi, negative 5 pi over 2, and that also goes on forever, right? So we're looking at what are all the ones between negative 2 pi and 2 pi inclusive. We see it's all of these. All right, so which means that we have 1, 2, 3, 4, 5, 6, 7, 8, 9. We already got 9 out of the 13. So we just need to get 4 more. So that was easy. Cool, maybe this isn't as long as we thought it was. Let's look at the second one. So the second one we said was negative 2 times the sine of negative x minus 1 equals 0. Just making sure that's what I wrote. Yep, that's what we wrote. Good. All right, so again, remember, so there's lots of ways we can do this, but like I said, the homework is probably going to be doing it like this. We want to make sure to have positive angles, positive values inside of trig equations. So for sine, what happens when you have a negative into a sine? If you remember, sine is an odd function. So what happens to negatives for odd functions? So they actually come out, right? So if you think about negative x cubed, that's just the same as negative x cubed, right? The negative just kind of comes outside of the parentheses. So we can see that's the same as negative 2 sine of x, right? Which is just positive 2. So positive 2 sine of x minus 1 equals 0. Which means that sine of x equals, if you add the 1 divided by 2, 1/2. So 1/2, oh, now we've come to something that's other than 0, right? So 1/2, it's not 0, not 0, not 1, not negative 1. So we have to use our triangles. So what's the first thing we ask ourselves with triangles? Which quadrants are we in? And it is quadrants. If you're doing it the way I'm telling you, right, where you do the 0, 1, or 2, or negative 1 with graphs, you should always end up with 2 answers for that question. If you have something other than 0, 1, and negative 1, you should come up with 2 different answers. So when we think of sine, what letter do we think of? We think of the letter y, right? So when is y positive? We see it's in the first quadrant and the second quadrant. We have 2 different answers. You need to make sure to remember that you are probably going to have 2 answers to that question of which quadrants is it in. All right. So sine is opposite over adjacent, so the opposite is 1. Sorry, opposite over hypotenuse, so the hypotenuse is 2. Which means what's going to be the adjacent? Well, you can either do the Pythagorean theorem or you can just know, because we talk about angles with 1 and 2. All right, well, that would be square root of 3. And now this should look familiar, right? What's the reflexive angle for the for a 1 square root of 3, 2? If it's across from the 1, we have 30 degrees. So for the first quadrant, what is 30 degrees in radians? That's going to be pi over 6. All right? So what equals pi over 6? X. X equals pi over 6. And if you thought, good, that was done, didn't do it right, what do we forget to put? Plus 2 pi n, right? We always put plus 2 pi n because sine is 2 pi, right? The period for sine is 2 pi. So we can list them out. So if we let n be 0, so again, we can make this a little easier. Make this over 6, so we multiplied that 1 by 6. We want to multiply this by 6 to be 12, right? So we can see that in this case, x is going to be, we can say pi over 6, 13 pi over 6, right? 25 pi over 6, so on and so forth. If you go in the negative direction, you're going to have negative 11 pi over 6, negative 23 pi over 6, so on and so forth. If we're looking at the one specifically between negative 2 pi and 2 pi, right? We know 2 pi and pi, or 2 pi is going to be 12 pi over 6. So which ones are within that? We see it's these 2. So we got 2. We got to get 2 more. And that's where the second quadrant comes into play. So for our second quadrant, so if we're in the second quadrant, how are you going to figure out what the angle is in the quadrant? Remember, we are starting from the positive x-axis. So this is the angle that we're trying to figure out. how do we figure out this angle? Well, the whole thing, right, if we went all the way here, whoops, that would be 180 degrees. But we're 30 degrees short. So what's that? 180 minus 30. So we are at 150 degrees. So what's that going to be in radians? 5 pi over 6. Another way to think about that is the whole thing is going to be pi, right? So if you are pi over 6 short of pi, you're just 5 pi over 6, right? You're 1 pi over 6 short. So we got x equals pi over 6, and we're done. And if you said yes or thought yes, you forgot something. Remember, we have to do this every single time. What do we forget? Plus 2 pi n. That's so important, right? Because we have 2 more that we have to figure out, and this only gives us 1. So if we write them all out again like we have done, right? So we got 5 pi over 6. We can, once again, turn that into an over 6, so 12 pi over 6. So 17 pi over 6. 29 pi over 6, so on and so forth. We can go in the opposite direction, right? Subtract 2 pi, or 12 pi over 6. So we subtract that. We got negative 7 pi over 6, negative 19 pi over 6, so on and so forth. So which ones are going to be between 2 pi, negative 2 pi and 2 pi? Well, since again, 2 pi is 12 pi over 6, right? We can see that these are the only 2 that are going to be between it, which are the 2 that we were missing. Do we have to double check ourselves? Do we have to check ourselves? No. We only started off with sine and cosine, so we are fine there. Do we have 13? Yes, we do. We outcounted them all, right? So those are going to be our 13 answers, and we're done. And actually, we're done with this section. Good. So if you have any questions, remember, you can always email me or text me. Let me know if any of this doesn't make any sense. But that's the end of the lesson.